welcome to the last session block of today. I hope you all had a nice future tech so far. Learned a lot. We're almost there, so bear with me. Today I want to talk about direct calls in Azure Microservices. What do I mean with direct calls? It's, if you Google it, I see terms like service to service, API to API, system to system. So what I mean with it, it's not a call originating from a client like a UI or a mobile app, but from a API to API specific. So what I want to do, and how we can secure them, that's the important part. So what I want to discuss today is a bit first problem. Why do we even need those calls? How do they differ from normal calls that originate from a client? And why it is important that we secure them properly, and how do they differ a bit. Secondly, this is definitely not a problem we've had since a short while. We've had a solution for it for a long time, but over time our own product has grown, more APIs were added, new insights were gained due to things we learn, new tooling became available. So we hit the point where we thought this solution no longer fits our way of working, so that's why we started looking for something new. For me, the beauty as a developer is for every problem you can think of, there probably are dozens of solutions, but due to requirements from business, from security, from our own development team, we can trim down the number of solutions we can pick and hopefully pick the best one that fits our current way of working. And finally, after we know what requirements we want our new solution to be part of, we actually look in what it is, how it works, and what it does. So before we dive into the problem, let's first get the weird question out of the way. Who's this random dude standing in front of you? I'm Erwin, developer at Virtual Vaults. Been there a little over 5 years. And at Virtual Vaults, we have a SaaS solution. It's a cloud-native app, runs in Azure, a lot of C#, .NET to keep it running. And every once in a while, we come across a problem, and we have a solution for it, and think, oh, that was a nice solution. We learned a lot from it. Maybe someone else might think so too. So, and luckily for us, somewhere at the Future Tech panel decided it was good enough for us to be here. So that's why I'm standing here today. So, first things first, I say direct calls, service calls in microservices. I don't think you need to be an expert in microservices to fully be able to understand what the problem is. But I think you, at least on a conceptual level, need to know a bit how a microservices architecture looks. So can I get a small raise of hands from everyone here who at least knows what microservices are? You don't have to build them, but yes? Well, it looks like a big part of the room, so that's nice. For those not raising their hand, I will go briefly over a small way how it looks. As you can see, I'm absolutely no expert in making nice images. But to get it a bit clear, we have a website, a client that calls some API gateway, can be like a reverse proxy that points us to all kinds of different microservices, compared to a monolithic architecture where you kind of have one application that holds all your code. The idea for microservices are that you split your code into different services, where each service then represents possibly like a specific business domain. The idea of each service is that they are independent. What that means is you can build, scale, deploy them separately, so they should never really interfere with each other. So if we look at this example, let's say the documents service handles uploads, downloads of files. If someone suddenly decides to upload 1 million files, it's nice. So in that case, only the documents parts need to scale up, not the entire application. And for example, if the payment service is down, you can still download your documents because they should be completely unrelated to each other instead of your entire application not responding properly. I'm not going to dive into all the advantages or disadvantages of microservices, but what I think is important for you to know is that with all the advantages microservices brings to the table, they also bring their own new set of technical challenges, and one of those technical challenges is the reason I'm discussing a problem here. So, problem we were having at Virtual Vault is because of the way it was set up, we ended up with a landscape that had many different APIs. I think we have between 10 to 15 APIs at the moment. And normally that's not a problem because they are designed to be independent, so they should stick to their own stuff a lot of the time. Unfortunately, some workflows we encountered, there needs to be a bit cross-service communication. When that happens, our first go-to approach is using an event-based solution. So we either send out an event or send out a message on the service bus, gets picked up by a different service, and that handles it, maybe creates a new event until the entire workflow is completed. But even though that's our first solution, we also encounter situations where that's not possible, not always possible, because we have a few cases where we need an immediate response or verify that something already happened before we can continue. In those cases, we use direct API calls. So then those are the few cases we do a direct API to API call. What I want to say. But they also need to happen securely. These are specific endpoints that are designed for this, so these calls are not originating from a client with a user token that's logged in and everything, so might even be originating from a webhook. Validation, level checking is completely different in these calls, and we are also not really broadcasting that they exist. Well, security by obscurity is never a good idea, so it's not the question if someone will find those endpoints, but more when will they find those endpoints. And when they find it and they aren't properly secured, they can either get information they shouldn't have from our system, or even worse, alter information in our system. Both cases we definitely don't want. So having this problem, we already had an old solution. I tried to make it a bit visible. So let's say the hypothetical case that we have an orders API that wants to make a call to a payments API. What we used to do is first generate a random string, a key, store it securely in Key Vault, and then when orders API said, I want to make my call, it went to Key Vault, hey, give me the payments API key, puts it on the header, and payments API then got that call, went to the same Key Vault, said, okay, give me also the payments API key, checked if the values were the same and said yes or no. Simple solution, works perfectly fine in the beginning for us. What we didn't like about it is if you have a key like this, it's good practice to every once in a while change it, rotate it, even if it got leaked out, you need to be able to change it. That's not possible if you have one key, so the proper solution had a second key next to it. So there was a payments API key 1, payments API key 2. You don't want to go to the Key Vault all the time, so probably some keys were cached in memory. Then you want to do the rotation, you don't want to do that manually, so we needed to build some automation for that. That was still fine if it was only 1 or 2 APIs that were doing it, but over time, everything was growing. So we ended up with having to build a full internal API management system to get this working. It's really nice to build, but unfortunately, it's not our core business, and we do have product owners that tend to nag that we actually have to build features for the customer every once in a while. So that's why we ended up with the idea this is no longer fitting for how we currently work, operate, and we started looking for something new. So first things we did is, what would a new solution require in it? Now, the first things, we have a really nice guy at the office. He's our security manager, and every time, or security officer, and every time we make changes security related, we go to him with a solution like, oh, we have this problem, and we think this is the fix for it. And 9 out of 10 times he says, if your solution is either a best practice or follows industry standards, he's already 80% convinced. So solution for us, industry standard, best practice, is probably a good idea to have. Next to it, we want something that's traceable / visible. What do I mean by that? Is we definitely don't want someone clicking around somewhere in the portal and say, trust me, bro, it's set up nicely. After a while, make some changes in there, and nobody really knows how it works. All code we write goes into Git repositories, there are code reviews. In a pull request, use stories are added, so any solution we think of for this should probably follow the same way of working, that we can fully trace back why did we ever add permissions to it, why did we remove permissions for it, etc. Next to it, we want something easy to maintain. Like I said, at one point we have the new solution implemented, but after a while, probably a new API might emerge, new permissions need to be added. The less code, the less work to make sure it keeps running, the easier it is to not make mistakes in it. So that's always a good thing to have for our solution. And finally, that's a bit specific also to our use case. It's nice that we have a fully working solution in the cloud, but while developing on new features, we first press F5 on our laptops to run it locally. It would be really nice if it also supports that flow, because else debugging will be a complete nightmare. With these requirements in mind, we went on to the Google, Bing, DuckDuckGo versions, and we came across Microsoft Identity Platform. It's a cloud identity service that, simply said, allows us to create applications where users can use their Microsoft identity to log into. It has a bunch of tools to protect APIs, endpoints, supports a ton of different use cases, workflows. We only need a tiny sliver of it. But what's important for us is that it has a OAuth 2.0 OpenID Connect compliant authentication service, which is nice, so we don't have to invent all that stuff ourselves. It has a ton of open source libraries, like the Microsoft Authentication library. What does that mean for us in code? We probably can just pull in a package and let it do all the magic, just set it up correctly instead of thinking, oh, how do I need to validate the signature of a JOT token? And nice thing extra to it is it has a application management portal, which gives us a nice overview, or we can easily see what is set up in it, what's visible in it, so that we can see what permissions we set, etc. So how does it look? This is stolen directly from the MS Learn website. It's a really high overview of the Microsoft Identity Platform, but on the, is this visible? Yeah. So on the top layer, it's just the Entra ID Admin Center, I think it's called these days. But how it works is just you have an app registration, then you use a client SDK to connect to that, to set up that, to connect to that app registration. That gives you a lot of endpoints to either generate tokens, identity tokens, access tokens, authentication, etc. And finally, you can set your target audience. Who do you wish to be able to do this through your or like which identities do you support. For us, it's just Microsoft Entra. We don't care about personal Microsoft account, Xbox accounts, etc. So with this in mind, how does our new solution look? I try to point it out in the same example. So we again have Orders API that once makes call to Payments API. And this time we started with creating a app registration, and our goal is to generate an access token from that app registration. So what we did with the app registration is we set it up that it only allows to work with objects that are linked in our own Entra ID. So that means everything that is inside Entra is able to interact with the app registration. Well, the first problem we have, of course, is an API can be a container app, a web app, virtual machine even. And by default, they don't exist inside Entra. Luckily for us, we actually solved this problem years before, because in the good old days, we used to connect to all other Azure resources, like storage accounts, key vaults, service bus with connection strings. And a few years back, we all changed that to use managed identity together with role-based access control. And for us, managed identity lives inside Entra ID, so all our APIs already have a managed identity added to it. In slides, you see both managed identity and user. That's because managed identity only exists in the cloud. We said we want a solution that also worked when we run locally. For us as developers, when we press F5, we are logged in locally with Azure CLI. Azure CLI I'm logged into as my own user, so that's why either depending on where I run the API, one of those two identities will be used to communicate with the app registration. So as soon as we have that set up, we can get an access token from it. So the app registration checks, is this identity coming from our own Entra? Yes, you get access token, else you get a big error. Then the following step is the same. It just puts it on the authorization header, and Payments API only needs to verify that the token is legit. How does it work? The access token we get back is a JOT token that uses a public-private key. So the signature of the JOT token is signed with the private key. In the header is information about which public key can be used to validate it. So the Payments API just needs to go to some well-known endpoint inside Entra with the public key information, gets everything it needs to know to validate the signature, checks if the audience is correct, checks if the issuer is correct, and if everything is okay, it says yay, else it blocks the call, and you get a 401 HTTP return response. This is just authentication, so the way, if we would just only do this, it's not just Orders API that can access Payments API, but actually everything that lives inside Entra, so every user, every API, every app registration, everything we ever created in there can now access Payments API. That's a bit much. So next to authentication, we also created something for authorization. So how can we do authorization in this flow? We have, on the app registration we create, you can create app roles. I have a slide with some examples in a few minutes. But after you create the app roles, you can do app role assignments, and that's actually where we make a link between a managed identity or a user and the app role we created. After you have done that, and you generate an access token, on your access token, it will now contain a roles part that has all the app roles that are assigned to you on it. And then you can encode a authorization policy that just says, do you have the required role to access this endpoint? First thing I want to say about the app role is it can be anything. There's absolutely no, only your own imagination is what's blocking you here. I just put some examples here, like what you can do, but you're fully free to customize this in any way possible. So you can keep it as simple as you want. If you look at the top role and you say, I just call it Payments API, so if you have an access token that says Payments API, I create a policy, and any service calls you make should be possible for you. Or you can go all the way to the other side and say, hey, these service calls, like we said, they should be really rare for just specific cases. So I'm creating app roles for just specific endpoints, and then if a single app needs to access 2 specific endpoints, just means he gets 2 roles on it. And you can mix and match this as much as you want. It's fully up to your own imagination. The only thing I want to say is keep in mind that the more app roles you think of for each and every one, you have to create a corresponding policy to authorization policy to check it, and make sure you make some good agreements with your team so that not one API has only 1 role and the next one has 6 in it. Just try to keep it similar across the board. With that said, time for a little demo. So, what I want to show in the demo is where's my mouse? Yes, there's my mouse. Just the creation process of the app registration. I would definitely say don't do this manually, but for me at least, seeing it done manually at least once managed to really click the pieces together for me. Let's call this a nice VisualTech demo live. First question we have, what kind of account types do we support? Like I said, we say single tenant, it's good enough for us. Even if we would say multi-tenant or like Skype, I don't even think that's possible anymore. Like without the app role assignments, even though you could technically get an access token if we would allow multi-tenant access, without the app role assignment, it's still useless because you're not getting past the authorization phase. But for this screen, this is enough. As soon as it's created, we need to set up a few things. Like I said, the app roles. You can create a simple app role, give it a name. So what we said, payments servers, payments API / specific endpoint. So you can create it like this. Allowed member types. Managed identities are applications in this context. But if we run it locally on dev, we are users. So in our dev environments, we need both. In our production environments, this is set to only applications. All fields are required, but we don't really care about the value that much. So we just fill it in like this. After we set this, we can go to expose an API. At the top, you see here your application ID, URI. If you click Add, by default, it just uses the application ID GUID to put in there, but we can make it also something nicely readable. So press Save. That's all we need here. So in the overview, you see here also the application ID, URI again, with it. And behind the app registration is service principal, the managed application in local directory. If we go to that one, we have users and groups here. And this is the place where we can actually make the app role assignment, in this case, user role assignment. Because for some weird reason from the portal, we can only select users. So I can say here, Erwin. Because we only set up one app role, I cannot select a different one here, else this would also be a list to select. You can assign it, and then because I'm zoomed in this far, you don't really see it. Where's my mouse? But if I would scroll to the right, No, let me zoom out a bit. It says here the role assignment. So that's really basically how to set it up. It's like, I don't know why we cannot do from the portal a application assignment, but in the end, your goal would be to do this from infrastructure as code anyway. So with everything set up, I have a small thing I ran before that is fully set up. So here we have like 2 example app roles. One thing added here, and this is a authorized client application. If you want to run this just in the cloud, everything's fine. But if you want to run it locally, because we are using, how say it? We don't want user consent or pops up in the middle of something. So we had to pre-authorize our Azure CLI application. So this GUID, if you would throw it in Google, you probably get a weird Microsoft application list back that it belongs to Azure CLI. So if you use something else to log in that is an application like PowerShell, you need a different GUID there. If you have a completely different way of authenticating locally, that's also fine. You might not need this. And if we would look at this user assignments here, because this one ran from some bicep code, you can also say I have here an orders API that has a service principal that has these 2 roles assigned to it. When you then go and generate a user token, I generated this up front. What we get is here the public key information. It needs to validate the name of the audience, the issuer, which is always sts-windows.net, and the last part is your tenant ID. And the important part for us is this roles section that just says, hey, you have these 2 roles set on it. Now, I said a couple of times, please don't do this manually, but use some infrastructure as code for it. So this is an example of how it could look. We use Bicep because we use Bicep for everything already. Ideally, you don't want to have this permissions per identity part inside here. I just did it to have everything in one file, but would probably best to move it to a parameters file. And then in theory, if you would ever say, oh, we now have a, this orders API needs to access something new, you would just add another API reader. And if this is run, it automatically adds that assignment to it. Or differently, if you would say, I think we can say required properties, we have another API, and that needs to also access the payments API. Just making these changes will allow us to add it for more APIs to slowly let it grow over time. So the idea is this is just in a code file somewhere, can have pull request, user stories linked to it. So that's easy. Traceable, rest of it, don't want to go into too much details, but yeah, this is just setting up of the application, the pre-authorized application, and doing the app role assignments. The actual version we have running in our code also generates or grabs some config stuff for it and puts it in app registration. I don't have an app registration in my demo environment right now, so that's why it's missing from this slide. That's a bit for the demo part. So what we have seen so far is setting up the app registration. What I didn't show you is, okay, how would it look from a C# point of view? How do we access it? So what we need first is a token credential. So if you've ever typed a new default Azure credential, new Azure CLI credential, new managed identity credential. All those things have an abstract class above them, which is the token credential, so all those things are fine to use. Next to that, at least in our solution, we use a delegation handler, so it's just a piece of code put on our HTTP client that says grab the access token every time just before we make a call. And finally, the application ID URI. Don't know if I showed it really nicely, but it's kinda... Where is it? It's, yeah, this value, basically. It's not nice if I just point to my laptop screen. This value. That's basically saying which app registration you want to connect to. So how would that possibly look into code? A small code example. So we see we have a request context that has the application ID URI. We have then token credential that just grabs the token. We get the access token. That access token also has a expiry time on it, so you probably want to cache it because it's a bit of waste every time getting the same access token back. Puts it on the authentication header and then just sends the request. And yeah, some programs use magic to make it work. So every time you would use the demo client, it auto-magically grabs a token, puts it on it, and sends it to the other side. So then we have the payments API that needs to validate the access token. For that, we have a really nice NuGet package, Microsoft Identity Web. When you pull that in, we get the add Microsoft Identity Web API authentication method that just needs a bunch of configuration. So which audience is actually that application ID, URI I've been talking about, client ID, tenant ID, etc. Once you've loaded in that configuration, you add an authorization policy, and it should work. So how could that possibly look? Yeah, you have here the Identity Web API, blah, blah, blah. So it just grabs the information from config. By default, it looks at the Azure AD config section. There are some optional parameters to make changes, give it a different scheme name if you want. And next to that example is just a authorization policy that says require role demo API. So that means everywhere you put authorized demo policy, as long as there's no demo API in the role list of the access token, it will give you a 403, else you can access it. Then some final notes. While implementing this, we noticed a few things I think are nice to at least mention if you plan on using this. Token lifetime. Inside the Microsoft Identity Provider, you can set up a lot of policies to influence token lifetimes, but at least last time I checked, not for managed identities. These tokens live for, right now, around 24 hours. They have some jitter in it so that they don't all refresh at the same moment. But if you want to use this, keep in mind that you should set it up in a way that you can roll out new permissions upfront for the rest of the code that actually relies on it. Else you might have some fun surprises. We do have some theoretical ideas how to work around this, but I think it's really specific to to your own use case, depending on how everything else is set up. But if you want to discuss, please come see me after the session. Next to that, local development. I also said it, for us, it's important because we use Azure CLI locally. We need to have that pre-authorized application for it. But yeah, depending on how your system looks, you might or might not need it. Because we use Bicep to add the permissions, it's just going through an array of app role assignments. That means if we would ever remove a permission from our file, it is not automatically also removed actually from the app registration. So this is a bit of a downside of it. Someone still needs to manually go to it and remove it by hand. And like I said, like I showed you, definitely find a solution, infrastructure as code to do it. We did Bicep, but our Bicep solution uses a experimental feature, which they say if you run it, you have a nice block, don't use this in production. We do it anyway. If you really don't want to do it, we had a previous solution for it that said, that use deployment scripts, so it's basically a bunch of PowerShell files doing exactly the same, because everything Bicep calls in the end is just a REST endpoint you can call yourself. But it was way slower, way uglier, and way less manageable, but you can do it. But then again, if you're using Terraform or Pulumi or whatever, like, you have to find ways around it. With that, I want to thank you for your attention. Hope you learned something. Hope you had a great day. And before we go to questions, I would say, if you have in tomorrow, next week, next month, say, oh, I want to look at this, and have asked questions, you can find me on these socials. I'm not the best social media guy ever, so bear with me. I try to respond, but it might take a few days. And please review my session so I can also learn from this experience. Yes, thanks.